Yes, my dear friends, in this lesson we will build our first project. In this project, we will control the LED diode connected to Arduino using the Python programming language. This will be our first and simple project we will do. Of course, in order to develop high-level projects in our future projects, we need to have a good grasp of the foundation and logic. The materials we will use in this project: first, we need the one piece Arduino Uno. Second, we need the one piece 220 ohm resistor. Third, we need the one piece of LED diode. Fourth, we need the one piece of breadboard. And the last one, we need two male jumper cables. Alright, so now let's start with our Python code. Alright, so now let's write Python code of our project. For this, let's move to our project folder and let's create a new Python file here. Let the Python file name be project1.py and let's press enter. And as you know, if you want to use serial communication between Python and Arduino, what we have to do now is to import serial module in our Python programming language. For this reason, let's import serial module and let's move to a new line. And in this new line, we need to call our serial class in an object. For this, let's create a new object here. Let the object name be, for example, Arduino, and put an equal sign and let's call serial.serial class and open and close parentheses. In the parentheses, we need to define two different parameters here. The first parameter will be our port name, and as you know, definition of the port name should be in a string data type. That's why I will create double quotes here and I will enter my port name, which is com5, and also put a comma, and let's define our second parameter, which is about baud rate speed. So I will enter my baud rate speed as 9600. So we are done. And also let's move to a new line. If we want to control the LED, what we have to do now is to create a loop here, and also the loop that we create must be infinite loop. So why? Because we get input from the user and user can turn on the LED or the reverse, and also user can terminate our code. So for this reason, let's create while true loop here and also put a colon, and let's move inside of our while loop. And in this while loop, we should to create a new variable here. The variable that we will create keeps the data from the user input. So let the variable name be, for example, data, and put an equal sign, and let's call our input function, and for example, turning on LED, press, for example, letter A, and also let's put a space, turning off LED, press, for example, letter B, and also open and close parentheses, and in the parentheses let's say press letter Z for exit, and also put a colon again, and let's move to a new line. So we are done. Let's explain it. If the user presses the letter A, we will send a signal as letter A to the Arduino. If the user presses the letter B, we will send the letter B signal to the Arduino board. So that is our explanation. Of course, we need to create conditions to be able to do these operations. So let's move to a new line and let's create if condition here, and also if the data variable is equal to letter A, let's send the letter A signal to the Arduino board. For this, let's call our object here, which is Arduino, and put a dot, and let's call our write method and open and close parentheses, and let's define letter B here, and let's create single quotes, and let's send the letter A data to the Arduino board. As you know, we have already learned what is letter B, so we don't need to explain it anymore. And also let's move to the while true indentation again, and let's call elif condition, and let's check the data variable is equal to letter B, and this time we will send letter B data to our Arduino board. And also let's define letter B again, and let's create single quotes, and let's define in the single quotes letter B, and we are done. And also the otherwise, let's check the data is equal to letter Z, and let's print this time, for example, bye bye. And also let's break our code, and we are done. Our Python codes are like this. Let's take a general look at it now. When we examined our codes, we first included our serial communication module in our Python codes. Then we called our serial class and assigned this class to the object we created named Arduino. So here is our Arduino object, and as you can see, we also defined our port information, which is equal to COM5, and the serial communication speed, which is equal to 9600. Of course, we do not determine the port information we define here according to our minds. When we connect our Arduino board to our computer, we define this port information as COM5 because we display this port information via Arduino IDE. After making the necessary definitions, we created an endless loop and entered this loop and asked the user to enter input to turn the LED on and off. We have assigned the entered value to the data variable. Thus, each value that the user enters will be assigned in the data variable. Afterwards, we observe that we have created our conditional structures. If the data variable is equal to the value A, we have created our condition to send the letter A signal as bytes to the Arduino board. Sir, why did we perform the data control in a string type here? I can hear you asking a question. Its response is defined as a string, whether numeric or character, when a data is entered into the input function. For this reason, we check the correctness of the equivalence as a string when looking at variable equivalence in our check operations. Continuing to review our code, we note that if the data variable equals the value B, so here, it should send the value B as bytes to the Arduino board. Our last conditional structure has nothing to do with Arduino. Since we created an infinite loop, we created our condition for our endless loop to end when we send the letter Z data from the keyboard to the program. Now that we have learned our Python code, so let's create an examined Arduino connection diagram of our project. Alright my dear friend, so now let's create and examine the Arduino connection diagram of our project.